Hello friends, welcome to VK Lectures. In this lecture, we are discussing the 19th and 20th question from physics question paper of Kset 2018. A planet moves in an orbit r of theta equal to I divided by 1 plus epsilon cos theta, where I and epsilon are constant. Under the influence of a force is given minus k r by r square. Now since this is in central force, you can understand this will obey Kepler's law. Now in central force there is one more property. Angular momentum is conserved. Angular momentum conserved means L is equal to mvr, which is equal to constant. Now since mass is constant, we can write v into r equal to constant. That means when v increases, r decreases, and vice versa. When v decreases, r should increase. Right. Now the question is, orbital speed of the planet is minimum. That means when v equal to minimum, we can say r should be maximum. Now here you have given r of theta. So r of theta should be maximum or will be maximum when I divided by 1 plus epsilon cos theta equal to maximum. Okay, when does this become maximum? When in the numerator is very large or increases, or your denominator decreases. Now here it is written I and epsilon are constant. The only variable is theta, because we know r is a function of theta. When that means your denominator should be less or minimum. When does this denominator become minimum? When cos theta is minimum. What is the minimum value of cos theta? That is equal to minus 1. When does cos theta become minus 1? When theta equal to pi. So this is what Kepler's law. When it is farthest away, your velocity will be less. When it is very near to this sun, your velocity will be more. That means the planet will move faster when radius is small and slow when radius is large. So theta equal to pi. So option D. Particle of mass m moves in a central potential. Central potential means the particle moves in plane. Okay. V of r equal to km r cube. The angular momentum for which the orbit will be a circle of radius a about its origin. Now if V of r is equal to cr power beta, then L square, that means angular momentum squared, will be equal to beta cm r power beta plus 2. This is the formula. Now we want angular momentum. So let us write what is L square. L square is equal to beta. What is beta? Now before going to that, let us write what is V of r. V of r is equal to km r cube. Now what is km? Km is nothing but c r cube, or here r power beta. So beta equal to 3, c is equal to k times m. So L squared will be equal to beta that is 3, c is nothing but km, so km beta c m into r power beta is nothing but 3, so beta plus 2. So that's equal to 3 times k m square r power 5. When a or radius equal to a, you can write L squared equal to 3k m square a power 5. Then what is L? Square root of this quantity, that is equal to root of 3k into m into a square into root of a. So that is nothing but root 3 times ka. So root of 3ka into ma square, ma squared. So what is the option? Ma square root of 3ka. So your option B. So what is the takeaway from this question is V of r, if V of r equal to Cr power beta, then angular momentum squared will be equal to beta Cm into r power beta plus 2. Please remember this formula. 21 and 22 are the questions for you to practice. Kindly find the answer and comment your answer in the comment box. We will be discussing the same in the next lecture.